In some jurisdictions within the United States, residential electrical wiring must be installed in conduit or electrical metallic tubing, or EMT. This requirement stems from local building codes and safety regulations designed to enhance electrical safety and mitigate the risk of electrical fires. Conduit serves to protect electrical wires from potential damage, including punctures, cuts, and exposure to moisture. BX, also known as armored cable, represents a type of electrical wiring encased in a flexible metallic sheath. Historically, BX was prevalent in residential electrical wiring but has been increasingly superseded by more contemporary wiring methods. Compared to conduit and non-metallic sheath cable, BX exhibits less flexibility, higher cost, and greater installation complexity. The implementation of conduit or BX for residential electrical wiring varies based on the state and locality. Several states may mandate or authorize the use of conduit, including California, New York, Texas, Florida, and Georgia. It is crucial to consult local authorities to ascertain the precise requirements in a specific area, as building codes and regulations are subject to change. The primary justification for employing conduit or BX in residential electrical wiring is safety. Conduit offers mechanical protection to electrical wires, thereby minimizing the potential for damage or exposure to hazardous conditions. BX also provides a degree of protection against damage, although its robustness is lower than that of conduit. Conduit installation generally incurs higher costs compared to alternative wiring methods like non-metallic sheath cable. This cost difference is attributed to the additional materials, labor, and time involved in conduit installation and the creation of necessary connections. BX is also more expensive than non-metallic sheath cable but less expensive than conduit. While non-metallic sheath cable remains the prevailing wiring method for residential electrical installations in Canada, conduit or BX may be mandated or permitted in specific jurisdictions within the United States to ensure safety. Despite the higher cost of these wiring methods compared to non-metallic sheath cable, they afford enhanced protection for electrical wires and contribute to improved electrical safety. Considering the various wiring methods available for residential electrical systems, it is helpful to understand the specific properties and applications of each, as well as the safety standards and regulations that govern their use. Firstly, let's delve deeper into conduit systems. Conduit, typically made of metal or plastic, provides a rigid protective pathway for electrical wires. This pathway shields the wires from physical damage, moisture, and other environmental factors that could compromise their integrity. There are several types of conduit, each with its own set of characteristics and applications. Electrical metallic tubing, or EMT, is a lightweight steel conduit commonly used in residential and commercial buildings. It is relatively easy to bend and cut, making it a versatile option for various wiring configurations. Intermediate metal conduit, or IMC, is a heavier gauge steel conduit that offers greater protection than EMT. It is often used in applications where there is a higher risk of physical damage to the wiring. Rigid metal conduit, or RMC, is the thickest and most durable type of steel conduit. It is used in demanding applications where maximum protection is required, such as underground wiring or in hazardous locations. Flexible metal conduit, or FMC, is a flexible conduit that allows for movement and vibration. It is commonly used to connect electrical equipment to a power source where some flexibility is needed. Non-metallic conduit, such as PVC conduit, is a lightweight and corrosion-resistant option. It is often used in underground applications or in areas where there is exposure to moisture or chemicals. The installation of conduit involves several steps. Firstly, the conduit must be properly sized to accommodate the number and size of wires that will be run through it. The National Electrical Code, or NEC, provides guidelines for conduit fill, which specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by wires. Secondly, the conduit must be securely fastened to walls, ceilings, or other structures using appropriate supports and hardware. The spacing between supports is also specified in the NEC to prevent the conduit from sagging or becoming damaged. Thirdly, the conduit must be properly grounded to ensure electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Now let's turn our attention to armored cable, or BX. BX cable consists of insulated conductors wrapped in a flexible metal sheath. The metal sheath provides mechanical protection for the conductors, but it is not as robust as conduit. BX cable is typically used in dry locations where it is not exposed to moisture or corrosive substances. One of the advantages of BX cable is that it is relatively easy to install. It can be bent and fished through walls and ceilings without the need for special tools or equipment. However, BX cable is more expensive than non-metallic sheathed cable, and it does not provide the same level of protection as conduit. The installation of BX cable also requires careful attention to detail. Firstly, the cable must be properly secured to boxes and enclosures using appropriate connectors. The connectors must be designed to grip the metal sheath of the cable and provide a secure electrical connection. Secondly, the cable must be properly grounded to ensure electrical safety. Grounding is typically achieved by bonding the metal sheath of the cable to a grounding terminal in the electrical box. In comparing conduit and BX cable to non-metallic sheathed cable, it is important to consider the specific application and the level of protection required. Non-metallic sheathed cable, commonly known as Romex, is the most widely used wiring method in residential construction. It consists of insulated conductors wrapped in a non-metallic sheath. Non-metallic sheathed cable is relatively inexpensive and easy to install, making it a popular choice for many applications. However, non-metallic sheathed cable does not provide the same level of protection as conduit or BX cable. It is susceptible to physical damage, moisture, and rodent attacks. Therefore, it is typically used in dry, protected locations where there is little risk of damage. In some jurisdictions, building codes may require the use of conduit or BX cable in certain areas of the home, such as basements, garages, or unfinished attics. This is to provide additional protection for the wiring and reduce the risk of electrical fires. The rationale behind using conduit or BX cable is based on several factors. Firstly, these wiring methods provide superior mechanical protection for the conductors. The rigid or flexible metal sheath protects the wires from physical damage, such as punctures, cuts, or abrasions. This is especially important in areas where the wiring is exposed to potential hazards, such as in basements or garages. Secondly, conduit and BX cable offer better protection against moisture and corrosion. The metal sheath acts as a barrier to prevent moisture from entering the wiring system, which can cause corrosion and electrical failures. This is particularly important in damp or humid environments. Thirdly, conduit and BX cable can help to reduce the risk of electrical fires. The metal sheath provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing a fire. In addition, conduit can help to contain a fire within the conduit system, preventing it from spreading to other areas of the building. The cost of conduit and BX cable is generally higher than that of non-metallic sheathed cable. This is due to the additional materials and labor required to install these wiring methods. However, the increased protection and safety they provide can justify the higher cost in certain applications. It is important to note that building codes and regulations regarding the use of conduit, BX cable, and non-metallic sheathed cable can vary from one jurisdiction to another. Therefore, it is always best to check with local authorities to determine the specific requirements in your area. In addition to the types of wiring and their installation considerations, it is important to discuss the National Electrical Code, or NEC, which provides comprehensive standards for electrical installations. The NEC is a widely adopted code that sets the minimum safety requirements for electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and safety practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians and electrical contractors to be familiar with the NEC and to follow its guidelines when installing electrical systems. Some key sections of the NEC that are relevant to residential wiring include Article 210, which covers branch circuits, Article 220, which covers branch circuit feeder and service calculations, Article 250, which covers grounding and bonding, Article 300, which covers wiring methods and materials, and Article 310, which covers conductors for general wiring. In addition to the NEC, there may be local amendments or requirements that must be followed. These local requirements may be more stringent than the NEC in certain areas. It is important to check with local authorities to determine if there are any additional requirements that apply to your project. When planning a residential electrical installation, it is important to consider the following factors: the size of the home and the number of electrical devices that will be used, the location of the electrical panel and the distance to the various outlets and fixtures, the type of wiring that is permitted or required by local codes, and the budget for the project. It is always best to consult with a qualified electrician to ensure that the electrical installation is safe, reliable, and compliant with all applicable codes and regulations. A qualified electrician can assess your needs, recommend the appropriate wiring methods and materials, and perform the installation in a professional manner. They can also help you to obtain any necessary permits and inspections. In summary, the choice of wiring method for residential electrical installations depends on a variety of factors, including the level of protection required, the cost, and the local codes and regulations. Conduit and BX cable offer superior protection compared to non-metallic sheathed cable, but they are also more expensive and require more labor to install. Non-metallic sheathed cable is the most widely used wiring method in residential construction due to its low cost and ease of installation, but it is not as durable or resistant to damage as conduit or BX cable. It is important to consult with a qualified electrician to determine the best wiring method for your specific needs and to ensure that the installation is safe and compliant with all applicable codes and regulations. Furthermore, understanding the specific requirements of the National Electrical Code and any local amendments is crucial for ensuring a safe and reliable electrical system. Consider a scenario where a homeowner is renovating their basement and wants to add new electrical outlets and lighting fixtures. The local building code requires that all wiring in basements be installed in conduit to protect it from moisture and physical damage. The homeowner consults with a qualified electrician who recommends using electrical metallic tubing, or EMT, for the wiring. The electrician explains that EMT is a lightweight and cost-effective conduit that is easy to bend and cut. The electrician installs the EMT conduit along the walls and ceiling of the basement, securing it with appropriate supports. They then pull the electrical wires through the conduit and connect them to the new outlets and fixtures. The electrician also ensures that the conduit system is properly grounded to protect against electrical shock. The homeowner is pleased with the final result, knowing that the wiring in their basement is safe, reliable, and compliant with all applicable codes and regulations. Now, let's explore some specific examples of conduit and BX cable applications. In commercial buildings, conduit is often used to protect wiring in exposed locations such as in warehouses or factories. The rigid metal conduit provides excellent protection against physical damage from machinery or equipment. In hospitals, conduit is used to protect wiring in patient care areas. The conduit helps to prevent electrical interference and ensures a safe and reliable power supply for medical equipment. In schools, conduit is used to protect wiring in classrooms and hallways. The conduit helps to prevent vandalism and tampering with the electrical system. In industrial facilities, BX cable is often used to connect motors and other equipment to a power source. The flexible metal sheath allows for movement and vibration without damaging the wiring. In residential buildings, BX cable may be used in certain areas, such as in basements or garages, to provide additional protection for the wiring. The metal sheath helps to prevent damage from moisture, rodents, or other hazards. In addition to the specific examples mentioned above, conduit and BX cable are also used in a variety of other applications, such as underground wiring, outdoor lighting, and security systems. The choice of wiring method depends on the specific requirements of the application and the level of protection needed. Moreover, it's crucial to adhere to the relevant safety standards and regulations when installing electrical systems. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, and local building codes may have additional requirements. Consulting with a qualified electrician is always recommended to ensure that the electrical installation is safe, reliable, and compliant with all applicable codes and regulations. Proper grounding techniques are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metal enclosures. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to the wiring and equipment. The NEC specifies the requirements for overcurrent protection, including the size and type of overcurrent protection devices, the location of the devices, and the coordination of multiple devices. Wiring methods and materials must be suitable for the environment in which they are installed. For example, wiring installed in wet locations must be rated for wet locations, and wiring installed in hazardous locations must be explosion-proof. The NEC specifies the requirements for wiring methods and materials, including the type of insulation, the size of conductors, and the type of conduit or cable. In summary, understanding the various wiring methods, safety standards, and regulations is essential for ensuring a safe and reliable electrical system. Consulting with a qualified electrician is always recommended to ensure that the electrical installation is performed correctly and in compliance with all applicable codes and regulations. The NEC is a comprehensive resource that provides detailed guidelines for electrical installations, and local building codes may have additional requirements. By following these guidelines and working with a qualified electrician, you can help to ensure the safety of your home and family. The importance of regular electrical inspections cannot be overstated. Electrical systems can deteriorate over time due to factors such as corrosion, vibration, and overloading. Regular inspections can help to identify potential problems before they become serious hazards. A qualified electrician can perform a thorough inspection of your electrical system, checking for loose connections, damaged wiring, and other potential problems. They can also test the operation of circuit breakers and ground fault circuit interrupters, or GFCIs, to ensure that they are functioning properly. Based on the inspection findings, the electrician can recommend any necessary repairs or upgrades to improve the safety and reliability of your electrical system. In addition to regular inspections, it is important to be aware of the signs of potential electrical problems. These signs may include flickering lights, tripping circuit breakers, or outlets that feel warm to the touch. If you notice any of these signs, it is important to contact a qualified electrician immediately to investigate the problem. Attempting to repair electrical problems yourself can be dangerous and may even be illegal. Only a qualified electrician has the training and experience to safely diagnose and repair electrical problems. Furthermore, consider the impact of technological advancements on residential wiring. Smart home technology is becoming increasingly popular, with devices such as smart thermostats, smart lighting, and smart appliances being integrated into homes. These devices require a robust and reliable electrical system to function properly. When planning a smart home installation, it is important to consider the power requirements of the various devices and to ensure that the electrical system is adequate to handle the load. It may be necessary to upgrade the electrical panel or add new circuits to accommodate the additional devices. It is also important to ensure that the wiring is properly grounded to protect against electrical shock and to prevent interference with other electronic devices. In addition to smart home technology, electric vehicles are also becoming more common. Electric vehicles require a dedicated charging station to recharge their batteries. These charging stations can draw a significant amount of power, so it is important to ensure that the electrical system is adequate to handle the load. It may be necessary to upgrade the electrical panel or add a new circuit to accommodate the charging station. It is also important to ensure that the charging station is installed in a safe and convenient location. As technology continues to evolve, the demands on residential electrical systems will continue to increase. It is important to stay informed about the latest advancements and to ensure that your electrical system is capable of meeting your needs. Regular inspections and maintenance can help to keep your electrical system in good condition and to prevent problems from occurring. Consulting with a qualified electrician is always recommended when planning any electrical work to ensure that it is performed safely and in compliance with all applicable codes and regulations. Remember that electrical safety is paramount. Always take precautions to protect yourself and your family from electrical hazards. Never attempt to repair electrical problems yourself unless you are a qualified electrician. Always turn off the power before working on any electrical circuits. Use caution when working around water or moisture. And never overload electrical circuits or extension cords. By following these simple precautions, you can help to prevent electrical accidents and ensure the safety of your home. Finally, consider the long-term benefits of investing in a quality electrical system. A well-designed and properly installed electrical system can provide years of reliable service. It can also increase the value of your home and make it more attractive to potential buyers. Investing in a quality electrical system is an investment in the safety, comfort, and value of your home. The expertise of a licensed electrician is indispensable for navigating the complexities of residential wiring and ensuring compliance with safety regulations.